Evet, benim panelimdeki uluslararası bilim insanları ve ticaret insanları Paskalya'dan dolayı ülkelerinde olduklarından ben onların yerine tek başına görünüyor olsam da arkada 3 kişi olacak. O yüzden de oturmayacağım. En sevdiğim şeydir sahnede gezmek zaten. İyi denk geldi aslında. Arkadaşlarım bilirler Türkçe bilmedikleri için şimdi. Konstantino Kinga, I'm on the stage now. You know my style. Yes. Uh, welcome. Welcome to Istanbul.
Hi, hello. Do you, do you
Hello.
hear me?
Yes, we could hear you very well.
Okay, thank you so much.
Uh,
So I,
Sorry. Let me announce your title and your abstract together. Evet. Bu section'ın adı, önce Türkçe söyleyeyim. Bu section'ın adı Sürdürülebilir Yeşil Teknolojiler. The title of this section is Sustainable Green Technologies. And I'm an environmental engineer. I'm a full professor in environmental engineering department of Niğde Ömer Halisdemir University, Turkey. And I am also general manager of a smart technology firm ALTEKNA. My partner is around here. Yes, in that section we have international scientists and also business person. First of all, I would like you announce you Kinga KORNIEJENKO, Associate Professor Doctor in Cracow. Cracow University of Technology, shortening CUT. The title of Kinga is Advancement in Construction Materials, Harnessing New Technologies for Sustainable Development. Türkçesi inşaat malzemelerindeki gelişmeler, yeni teknolojiler, yani sürdürülebilir gelişme için yeni teknolojiler tarzında. Kısa bir özet söyleyeyim. Kinga's presentation is about new trends in construction materials. Firstly, current area of innovations are presented and discussed. Secondly, the main trends connected with building materials. And thirdly, she focused on details on green materials, advanced materials, 3D printing. All of them showed in the same speech. Finally, the further areas of development are summarized from Kinga and Janusz MIKULA, Professor Doctor and Dean of Materials Faculty of Cracow Technology University. Yes, please.
Thank you so much for nice introduction. Just very shortly about both of us. We are working on the Faculty of Material Engineering and Physics, and because of that, this presentation will be focusing on the materials topics. Especially about the geopolymer, there are environmental friendly material for the construction industry that we are all working on this class of material, and we think that it is very important for the future development of construction technologies. A little bit about predicted development on the construction industry. The areas are connected with, especially the types are using the 3D printing, smart materials, green building, and on these three topic I will be speaking in this presentation because it's not so much time to speak about everything, but it is also important to stress that nowadays also the traditional material, traditional technical achievements should be joined with some kind IT technologies, and also according some statistics, some forecast, the next 2 decades, the very important for the development building technologies will be important. The big data, the artificial intelligence, as in many industries, also Internet of Things, also the automated systems such as building information modeling, and also some kind of support this technology as virtual and augmented reality that allow to better understand and better visualize some kind of topics. And also the drone technology is predicted that it will be development quite quickly. Now I go to these three technologies. I started to the green building. As I said, my presentation will be connected with geopolymers, and firstly I would like my co-speaker through some movie present you what are the geopolymers. The movie is in Polish, but it will be with English subtitles.
Geopolimery to bardzo specyficzny materiał. Niektórzy nazywają go polimerem nieorganicznym ze względu na jego budowę strukturalną, która składa się z łańcuchów krzemu i glinu. Między innymi z tej budowy wynikają dość oryginalne i specyficzne własności geopolimerów. Jest materiałem szklistym, bezpostaciowym, co zapewnia jego olbrzymią żaroodporność i żarowytrzymałość, o wiele wyższą niż klasycznych materiałów budowlanych. Ma wiele specyficznych cech, w związku z tym takich jak wysoka wytrzymałość na ściskanie, wysoka wytrzymałość na zginanie, odporność. Wszystkie te cechy predestynują ten materiał do zastosowań w budownictwie. Szczególnie to, że ma zdecydowanie niższy współczynnik przewodzenia ciepła niż właśnie klasyczne materiały budowlane.
Sorry for that. I just back to sharing. Some kind of small problem. Yeah, it should be okay now. Yeah, and that. Sorry for this technical problem. As you see, very shortly about the geopolymers, what they are. And now I would like to show why they are so nice material for if we just consider sustainable development. Firstly, the geopolymer can maybe produced from some kind of industrial byproducts. These industrial byproducts are the fly ashes, as you see on the down picture, and also the coal gouges. So the waste from the mining production. Actually, a lot of materials that is rich in the alumina silica can be used for the geopolymers manufacturing. Also some kind of construction and demolition waste and other waste with glass structure. The second reason is possibility to obtain these materials from using for these materials also some kind of reinforcement from the renewable materials, including the fibers. It was one project that we also have with the Neslihan University. We there investigated the possibility of reinforcement our geopolymer material from some kind of natural fibers, and it gives us very nice results. You see some kind of possibility to do some solid structure from these materials, also some kind of foam structures. And it was mentioned during the movies that these materials have excellent thermal properties, so they can be used in building construction as isolation materials and eco-friendly materials, what is quite important nowadays when we think about lowering CO2 footprint. The second topic, there are the smart materials, also some kind of investigation. Our investigation was connected with that topic. We go further with this reinforcement by natural fibers. We obtain the material that have a very nice fire resistance. They have high isolation properties. As you see, these properties are comparison for the standard isolation materials, but in the same time, this material have a reasonable mechanical properties, and it can play also some kind of roles in during in the reinforcement, some kind of walls or some kind of internal construction. Also, the advantages is CO2, low CO2 emission. It is because this material is produced at in low temperature and do not require such, it's not such energy consumption as production of the traditional concrete. We also try to add to this material some kind of mycelium, so kind of a fungi reinforcement. Also, we create this kind of composition, and this composition also working very well according to as a building material for isolation purpose. This kind of materials was rewarded. We have also some kind of patent for this kind of invention. Additional advancements, as I said, is possibility to use some kind of mine tilings. We use the mine tilings for the coal production. There is some kind of huge problem in Poland with some kind of waste. As I know, also the Turkish economy based on the coal energy. So also this kind of waste can be found also in Turkey. Also, we do some kind of trials with the fast change materials. This to add to the geopolymers, we tested the 3 types of fast change materials. The idea is to create the wall that will be absorb the heat during the day and release inside the room this heat during the night, what allow to us to save the cost of the energy and steering the temperature during the whole process of industry. And also a little bit about the 3D printing technology. We employed to the 3D printing technology for production the geopolymers because the statistics shows that this technology are environmental friendly and more efficiency than the traditional one. Of course, now the 3D printing of concretes or geopolymers is just a technology that exists in something like the small scale. Only a few installation has been made during the last 10 years on the world. One of the projects that we are involved of as consulting people was made from the Laporanta city. It also involves some kind of side streams as ashes, as also mitalings and other byproducts to production the geopolymers that they were used for the 3D printing of some kind of city structures. Here you have some kind of feature from the project. The first, it was made in the laboratory scale, but by using the robotic arm. The secondly, the some kind of middle-sized 3D printer was used. And it allows to create for us something like elements that you see in the right corner, upper corner. These elements that was used for the building the wall noise between the railway train, and also and the garden. It's of course the main function of this construction was protection against the noise. Some kind of calculation from that project. As you see, usually the LCA is lower in the case of the geopolymer material. But if we do not focus it of the proper ingredients of this that are the base for the geopolymer, as you see on this graph, it could be also a little bit higher. It is depend what we actually used. The recommendation is actually use the material that are locally available, so it is important to employ some people to optimize the recipe. In this graph, I just would like to show you that in the case of the assessment of LCA, it is much better in the case we use the 3D printing. The bars just we present for the 3D printing are much lower than in the case of casted. It is a result the lower waste manufactured during the production some elements, also the more efficient using the materials, and if we speak about generally efficiency of this material, also the advantages is employing the lower amount of the employees that have to work on some kind of specific construction. Also, we have some kind of other tools with implementing.
Sorry.
Yeah.
Kinga, 4 minutes left.
Okay.
Thank you.
With implementing some kind of fibers inside the geopolymer during the 3D printing process, it also works efficiently. Just I skip this kind of movies for because of the time. We also participate in the project that allow us to 3D printing some elements using the red matte waste. So they're the waste from the aluminium production. Also, they give us some kind of nice results. Here are the some kind of elements that we print for the end of this project actually for the final exhibition on this in the 2023. What it started doing now, we just try to a little bit work for the more advanced material, for the material that could be possible to use in the production of the space shelter. In the small project provided from my friends, she tried to create something like artificial regolith, artificial soil for the something like the same composition as on the moon. And of course, the step further 3D printing it, because it's only one technology that is have a sense in the space production. Also, we try to investigate the mentioned earlier isolation material through the 3D foaming, but it is not easy. And we also try to use the geopolymer for the 3D printing underwater infrastructure or just protection of the wreck, also using some kind of industrial byproduct. In the case of this material, we also investigated some kind of hybrid materials, connected organic polymers and inorganic polymers, and do some trials, as you see on some kind of huge 3D printer. Investigate this material as a potential material for protection the wreck. What for the protection the wreck is needed? Why this protection the wreck is needed? Because they very often corroded, and in the Baltic Sea we have a problem that after the Second World War we have a lot of wreck that have a potentially hazardous substances inside, and these hazardous substances they probably will be released during the next decade. Because of that, we have an idea to just protect it on the site, because it is much cheaper than taking from the ground all the wreck and just to or try to pumping the hazardous substance for that. On the slide, you see our trials during the put this material and 3D printing in situ. As you see, there is still some kind of problem with material coherence to our underwater construction. So summarizing, I show you some kind of 3 main trends connected with the development, the building materials, actually connected geopolymers in that period. We try to develop the green material that are not for only the simple application, represented by different kind of fibers and different kind of other materials. Especially interesting, there are phase changed material, because they give us something like the smart construction, and we try to develop also the 3D printing technology as a more effective for this material. So thank you for your attention, and if you have any question, you have also the contact for me, and do not hesitate to write on my email or.
Thank you, Kinga. Your timing is very perfect, as usual. Yes. Thank you for you, not only for you, but also Janusz MIKULA, for the as dean of your faculty, and please send my best wishes to your all team from Poland. I love you so much.
Thank you so much.
Thank you from.
Unfortunately, Janusz MIKULA couldn't be here because some kind of personal affairs.
Yes, you are holiday, important holiday day for you, Pascalia. I know that. We wish you a good luck in your ceremonies. Thank you.
So, thank you so much. Bye bye.
Bye bye. Şimdi ikisi bir arada konuştuğu için 20 dakika ben süreyi tuttum. 20 dakikalık süreyi iyi kullandılar. Birinci ve ikinci sunum arka arkaya oldu. Videodaydı Janusz MIKULA. Videodaki konuşan dekan oydu. Prosesi anlatan. Öyle bir çözüm buldular Paskalya'dan dolayı. O büyük bir seremoniye katılacaktı dekan. Kinga da incelik yaptı, katıldı. Şimdi o da koşacak seremoniye. Şu anki konuğumuz 10 dakika konuşacak. Çünkü tek kişi konuşacak. Üçüncü kişi, onu hemen anons ediyorum. O da çünkü büyük bir seremoniye katılacak. O da önemli bir iş insanı. Konstantinos.
Yes, hello. Hi, Neslihan.
Yes. How are you?
I'm very well. You know, we have a Greek Easter today.
Yes,
here
yes,
I'm in
Easter
Athens,
today. Yes,
but,
Paskalya.
Yes, I'm very happy to be with you because we know each other for a very long time. We have a very close cooperation, so I had to be there.
Thank you.
Unfortunately, I was not physical presence, but it was very nice to be here.
Thank you. Thank you for your accepting our invitation. You know that Easter time is very important for you, and we have in the same time in for Greece, and I would like to invite you from our audience. Let me announce your title. The role of innovation in the European Union's circular economy policies. Konstantinos Aravossis is the chair of UNESCO circular economy, and also he is the business entrepreneurship and businessman in Greece, and full professor in Athens Technical University. And he concentrates on, first of all, European policies, and then innovation, and focusing also the role of innovation in CEA policies, importance, support, European Union support and innovation, and European Union policies and innovation, and single-use plastics, SUP, an exemplary opportunity for innovation. And then you will show you conclusion, and considering circular economy main features, pillars, and national circular economy plans, and also Greece case study for you. Yes, thank you.
Okay, thank you very much for the introduction.
Thank you. You have 10 minutes.
How many minutes? 15 minutes?
10 minutes.
How many?
10 minutes.
Okay, 10 minutes. I will try to do it quick and efficiently. Okay, let me share my presentation. I will try to share the presentation. Can you hear me?
Yes, we could hear you very well.
Can you see something? Can you see my screen?
Yes.
Okay, you can see the screen now, yes? Okay, as you mentioned, I'm going to talk about the role of innovation in the EU's circular economy policies. I will make an introduction to the European policies that deal with circular economy and the climate change. It all starts from the climate crisis and the climate change policies for reducing emissions and adaptation. It all started with the Paris Agreement, 2015. There are the 17 Sustainable Development Goals with the different 169 targets. Within them, circular economy, where I'm going to focus in this presentation, plays an important role. It is included in more targets of the SDGs. There is an EU action plan for the transition towards the green economy. As you know, the target is 2050 to become climate neutral in Europe by 2050. There are different policies that play a role and that can lead us there, starting with the clean energy transition, where it is very important to move from traditional energy sources to renewable energy sources. There is an industrial strategy for the competitive green, digital, and I would say circular Europe. We have to transform the EU into, and also buildings in the EU have to have more energy efficiency. Smart mobility plays a role. Conservation and restoration of ecosystems and biodiversity, the development of a friendly food system, and the ambition for zero pollution and a toxic-free environment. Here you can see the different initiatives that are associated to this. As I mentioned before, the last point here is very important. The circular economy policies that deal with resource reuse, repair, recycling, and leading all this to zero waste. There is a target 2030 to divert from landfills 90% of waste. And so this is a target that can only be achieved by having higher recycling rates. The target is by 2030 over 60% recycling rate. And all different technologies, including energetic use, energy utilization, waste to energy technologies, in order to achieve this 90% diversion from landfills, which means that you have to use waste either as raw material, as inputs in the production chain, or through energy use. You can see that 2020, the European Commission has approved the new Circular Economy Action Plan, which is based on the European Green Deal. The European Green Deal, as you know, includes all the measures that Europe has to take into account in order to achieve the 2030 targets. And there is a lot of financing behind that, because you need a lot of investment in order to achieve the targets for, first of all, for 2030. Here you can see the action plan, where there are, here I present the three instruments, European policies that are associated to circular economy policy and the circular economy EU plan. It started with the Waste Framework Directive, the Eco Design Directive then, and here I'm going to give the case study of Single-Use Plastics Directive, which is, it has been put into application to use already 2019. All EU countries now have have already stopped the 10 most commonly found single-use plastics on European beaches. They have been banned. 10 specific products.
Konstantinos,
Yes?
you have 4 minutes.
4 minutes, okay. Here you can see that very important is the innovation drives, which drives the transformation towards a circular economy by enabling systemic change across the value chain. And I will go, you see, I've mentioned that there are financing opportunities in Europe as Horizon 2020 and the EIT Climate Kick, for example, that can finance this change. Now, there is an exemplary opportunity for innovation in single-use plastics, what I mentioned. There is an action plan where plastic pollution is identified already as one of the main pressures on healthy oceans at the International Ocean Conference, already 2017. And you can find over 60% of plastic pollution, plastic waste in the wastes that you find in the beaches. And of course, also in the sea, you find a lot of waste. So by 2030, all plastics packaging placed on the EU market has to be either reusable or it has to be recycled in a cost-effective manner. As I mentioned, more than half of plastic generated is recycled. A separate collection of plastics waste has to reach very high levels. 60% should be the overall recycling rate. and the EU plastic recycling capacity has to be extended, modernized, and there you need to substitute the plastic that is already banned by new kind of plastic, by new materials. You need innovative technologies. It is important to improve the economics and the quality of plastics recycling, to improve the design, and there you need again support innovation to make plastics and plastic products easier to recycle, to expand and improve the separate collection of plastic waste. Again, there you need special technologies to ensure the quality inputs to the recycling industry, to expand and modernize the EU sorting and recycling capacity. Sorting also, as Professor SAÐΛΑΜΤΙΜΟΥΡ knows, Neslihan, you need special technology for sorting and for recycling. And you have also to create viable markets for recycled and renewable plastics, because maybe even if you have the product, you have to use it, so you need the market. So the innovation can help to reduce the costs of existing solutions, provide new ones, and amplify the potential benefit beyond Europe's borders. It's not only the EU, it's also the partners of the EU that have to cope with the EU policies. I mentioned that there is a lot of funding. What you have to do is to support circular economy by encouraging the idea of eco-design, producing long lifespan products, repair of existing products, so you have to have a higher time cycle of the products, and there innovation is the prerequisite, so you need to develop new technologies. In Greece, this is we have already the circular. I give this as an example of an EU country. Greece has a circular economy plan, a 4-year circular economy plan. It includes plastic, but also all policies that have to do with circular economy. And there you have 5 pillars. You need to have policies concerning sustainable production and industrial policy, concerning sustainable consumption, which is also an issue. You have to have less waste with significant value. So you have also to omit by design the production of waste. And there are special actions for priority products like single-use plastics, I mentioned before, but also horizontal activities. So to conclude, it is integral to have innovative technologies to the EU circular economy policies in order to have success. Plastics is an example of the intersection. Here you have the intersection of environmental challenge and a lot of innovation potential to achieve the targets. And here you need the continuous support for research and development. You have to cohere to policy, as I mentioned, in order to achieve the 2030 targets and the policies that are associated to them. You need to apply new technologies, and of course education goes with it, and it is very essential. So to conclude, the key enabler of circular economy transformation, what I mentioned in the beginning of my presentation, the way to a green, sustainable and circular economy, for all different markets, is you have to unlock long-term sustainability, economic competitiveness, and climate in order to achieve the climate goals across the EU and all the countries included in the EU.
Yes, it is the final time of this session, because Subadriyah the last presenter of this session. Now she is in hospital from Universitas Nahdlatul Ulama Jepara in Indonesia. Therefore, I would like to close this session. Türkçesi son konuşmacı şu an hastanede olduğu için kendisi bildirdi. Oturumu kapatabiliyoruz. Bir özetleyeyim. İlk iki konuşmacı zamanında bitirdi. Son konuşmacı 3 dakika ile bitirdi. O sayede dördüncü konuşmacı da olmadığı için biz aslında hedefin üstünde bitirmiş olduk. Çünkü dördüncü konuşmacı için bir 15 dakika süre vardı. Arada işte bir 10 dakika ona 5 dakika benim sunumuma derseniz programdaki kaymaya da dikkat ederseniz aslında tam zamanında bitirmiş olduk. Önce bitirmiş olduk hatta. Kahve için yeterince zaman kalmış oldu. Çünkü bir sonraki oturum sanıyorum 50'de mi başlıyor Sevinç Hocam? 12.50 değil mi? Tamam, süper. O sayede şey yaptık. Çok önce bitirdik. Herkesin yeterince kahve zamanı var. Thank you for timely presentation. Yes, now is coffee break, but please let me announce your certificate of appreciations. I'm taking your certificates and will transfer not only you but also Kinga and Janusz together. Will transfer you online for your certificate of appreciations. Please.
Thank you very much. Thank you very much.
Thank
It was a pleasure to be there.
Thank you.
Thank you so much.
Thank you. Happy Easter.
Pardon,
Pardon, bizim sertifikalar. Sorry. She is announcing your certificates.
Neslihan Hanım'a ve tüm katılımcılara çok teşekkür ediyoruz. Çok değerli bilgiler aktardılar bize. Evet, ben teşekkür belgelerini vermek üzere TÜYAFED Genel Başkan Yardımcısı Sayın Mehmet Ali Altun'u sahneye davet etmek istiyorum. Mehmet Bey buyurun. Hem katılımcılara hem de Neslihan Hanım'a plaketini ve teşekkür belgesini takdim edin efendim.
Mehmet Ali Altun is the Vice Chair of Turkish Software Federation. Yes, he is presenting your certificate of attendance.
Thank you very much. Thank you very much for this. It's a pity that I'm not there to be with you.
Thank you so much.
Thank you.
Evet, Mehmet Bey teşekkür belgelerini de takdim etsinler. Gösterebilirsiniz de.
Yes, it's for Associate Professor Dr. Kinga KORNIEJENKO, and it's for another one. Janusz. It's for Janusz MIKULA. Yes.
Thank you so much, and I hope next time I will be on place.
Yes, you will be in Istanbul next time. Thank you. And it's for Konstantinos Aravossis. Yes.
Yes, thank you very much again.
Bye. Happy Easter.
Bye. Yes, thank you. Thank you. Bye.